Welcome to our next instructional video that goes through what is referred to as combining functions. Back in earlier courses, you've learned some basics of function notation. So we're going to elaborate a little bit upon your current knowledge of function notation and extend it to involving multiple functions. Now, if I just back up for a second here, just to refresh your memory, so you may say, I don't even know what he's talking about when he says function notation. Remember back grade 10, I think we've even looked at it a little earlier this year. If I said f of x is 3a squared plus 7, I said find f at 3. That means replace x with 3, and you would have 9 times 3 is 27 plus 7 is 34. That is called function notation. So all of you at some point have worked with that. So in this section, the final one in this unit on functions, we elaborate upon that and we look at how to combine multiple functions together. The first one is called combination of functions. And then the second type of grouping together of functions is what's called composition of functions. And they are handled slightly in a different manner, and the notation is slightly different. So that becomes a key factor here. So if you've got any two functions, f and g, you can combine them to make new functions by adding them, subtracting them, multiplying them, and dividing them. And it would be just as you would expect. So if you have f plus g of x, like so, it is the same as f of x plus g of x. If you have f subtract g of x, that means take function f of x and subtract g of x. fg side by side, or could also look like this with a little tiny dot. And this x does not have to be in brackets. Sometimes it is, sometimes it's not. And sometimes it's not even there. Sometimes you'll just see f dot g or fg. That means function f of x times g of x, and then f over g means function f of x divided by g of x. I'm not going to get too involved in the domain and range of them in this video. I'm just going to look at kind of the notation and how it works. If I had two functions, g of x and f of x, and this says to do g minus f of x, well, that means to take function g of x and subtract function f of x, which means take g of x to be 2x plus 5. Now this is the key. F of x needs to go into a bracket. Put function f of x into a bracket. Now we're going to distribute, so you're going to get negative 3x and a plus 2x, so negative x, 5 minus 1 plus 4. That's it. That's g of x minus f of x. These numerical ones, you can do it the same. So when it's just a dot, as you see here, that means to take function f of x and multiply it by function g of x. Now this one is not x, so it's negative 1. So there's two ways you can do it out generically first. I guess in this one it's not, it's t, I guess, not x. So f of t is t minus 3. G of t is t plus 4. You could multiply them out and get t squared plus 4t minus t, 3t, which should be a plus t, minus 12. And then at the end, so this is f dot g of t. And then after you do that, do f dot g evaluated at negative 1, which means put negative 1 now in for the t's. Negative 1 squared plus a negative 1 minus 12, which is 1 minus 12, which would be a minus 12. The other way to do that same question, which is I think what I probably prefer to do with these, is right at the beginning, figure out f at negative 1 and multiply that by the answer you get when you do g at negative 1. So f at negative 1 means go up to function f, put negative 1 in for t. So it's going to be negative 1 minus 3. And then go to function g and substitute negative 1. So g, and put negative 1 in here. So negative 1 plus 4. Negative 1 minus 3 is a negative 4. Negative 1 plus 4 is a positive 3. and it gives you the same answer. So this is do your function combination first, then substitute at the end. This is substitute right away and then multiply. If I look at the next two, this is another generic one, so it's just add a variable n. So it wants us to do g plus f of n. So that wants us to take g of n and add it to function f of n. Well, g of n is 4n plus 2. I'm going to add to that function f of n, which is negative n squared subtract 4n. Group this stuff together, we're going to get negative n squared, 4n, and a negative 4n. Notice it's a plus, so I'm not going to have to change any of these signs. Those two eliminate each other. There is g plus f of n. G divided by f at negative 7. That wants us to do function g. I'm going to do it this way. I like to substitute and then do my division at the end. So g at negative 7, and then I'm going to do f at negative 7, and we're going to divide the answer. So g at negative 7. Put negative 7 in here. 4 times negative 7 is a negative 28, minus 3, negative 31. F at negative 7, 3 times negative 7 is a negative 21. And that would not reduce. Our final answer would be the fraction 31 over 21. So that's called combining functions or combinations of functions. The next thing I'm going to show you is what's called composition of functions. It's when the input of a function is actually another function. So for example, and there's two ways you'll see it written. This way is where you have the double bracket, so it's f evaluated at g of x. So that's telling me to put g of x in the place of x in function x. It's the same thing as if this had been f at 0, it would say go to function f, where there's an x, put a 0. Well, it doesn't matter what's in these brackets, it's what we substitute in the place of the x. So in this case, and I know it gets confusing because you get an x here and an x here, but this is saying put g of x in function f where the x sits. And it says here, it's read f of g of x. Or it's the composition of function f with g, meaning you're going to put g into function f. It can also be written with this open circle. Now you got to be very careful with this because f with a dot closed in, g of x, means f of x multiplied by g of x, versus f with the open circle, g, looks like the letter or the word fog, that means f evaluated at g of x. So you're going to put g of x into function f. So that small open circle is very important that your writing is neat enough we can distinguish the difference between the open circle and that closed in dot because they mean different things. So if I just took the two functions you see up here and I wanted to do f of g of x, this means go to function f, where there is an x, replace it with g of x. So 3 instead of x, put g of x plus 2. But now I actually know what g of x is. G of x is this other function 4x minus 5. So I then go 3. Instead of function g of x, I actually put its value here, which would be 4x subtract 5 plus 2. This now becomes 12x subtract 15 plus 2 minus 13. Compare that with if I do g of f of x. So this time it's telling me go to function. Again, it's just like someone giving you a set of instructions to get from point A to point B. You got to know how to follow the instructions. This is telling me go to function g. Let me look up above here. So function g is the one 4x minus 5. And where there's an x, right, where there's an x, there's now an f of x going to be substituted in its place. 4 instead of x, we're going to put, not g, f of x in the place of x. and then we'd have our minus 5. Then we replace f of x with what f of x is equal to, which is 3x plus 2. So this g of f of x will equal 4 onto 3x plus 2 is the value of f of x, minus 5. And now we would just multiply this out. So 12x plus 8 minus 5, 12x plus 3. That's g of f of x. So this one could have also been written g, open circle. A little hard with these pens. So g, open circle, of f of x. This could have also been written, and I would have done it the exact same way. It can be in brackets. It doesn't have to be in brackets. Both are the same. So it is, you'll see here, this is what it, commutative means if you switch the order like we did here, you'll notice you didn't get the same answer. There are situations where you will, but in this one it shows you that it's not always commutative. You don't get the same answer. Okay, so let's look at these ones where we want to do f at g of 4. Well, what I like to do with these ones with numeric examples is similar to, so if I was doing this one here, f at g at 4. I like to figure out g at 4 first and get the actual answer for it. So g at 4 would be 4 times 4, subtract 5, 16 minus 5 would be 11. Then replace g of 4 with its numeric value. So instead of f of g of 4, well, I know that g of 4 can be replaced with an 11 because they're equal to each other. So now I go to function f and I put an 11 in for the x. And that gives me 33 plus 2, 35. All right, look at this next one. G of f of 4. So G of, that's a close or an open circle, G of f of 4. So that means find function f of 4 first. Function f at 4 is 3 multiplied by 4 plus 2, which would be 14. So now it wants me to find g at that value. So g at 14 is what I would need to find next. So g at 14 would be 4. G at 14 minus 5 gives me 56 minus, so 51. If you look at our third example, which is f of g of x. Now this one's not a numeric example, so it's telling me go to function f, and replace x with g of x. So it's 3 instead of x. I put g of x in its place. And then I have my plus 2 still there. And now replace g of x with the actual function value of g of x, which would be 3 multiplied by 4x plus 5 plus 2. And then you just clean this up. So that would give me 12x plus 15 plus 2. There's f of g of x. And the last one is in the other notation, so g of f of x. So it wants me to put f of x into g of x. So g of f of x would be function g, which is 4x minus 5. So 4, instead of x, it wants us to put f of x in its place. And that was minus 5. And now replace f of x with the value of f of x, which is 3x plus 2. So that's 4 onto 3x plus 2 minus 5, 12x plus 8 minus 5, 12x plus 3. All right, so this is called composition of functions, and this is where you substitute one function into another function. So not just a single letter, it's a whole function getting substituted. But it's really the same thing as you would have done. So f at 11 means put an 11 in for x. F at g of x means put a g of x in wherever there was an x in this function. Let's look at these two. So it says find f of g of x. Here's your two functions. So if I do f of g of x first, f of g of x, let's do it down here. F of g of x says go to function f, there's function f. Instead of just an x, replace the x with g of x. So it's 3 g of x squared plus 2 times g of x plus 1. Well, instead of g of x, put the actual value of g of x. So 3, I'll color code this one as best I can. So that g of x is 4x minus 5 plus 2. G of x is 4x minus 5. Got my plus 1. Go back, don't forget my exponent. And now you expand out this polynomial. So you're going to get 3 binomial squared. Square the first, multiply and double, square the last one, plus 8x, subtract 10, plus 1. And that would give me 48x squared. Take away 120 plus an 8, so that's a negative 112x. 3 times 25 is 75. Plus 1 is 76. Minus 10 would be plus 66. There's the value of f of g of x. Okay, let's do g of f of x. Number 2. G of f of x. So g of f of x wants me to take function g. Now function g was 4x. So g of x, just to remind you, g of x was 4x minus 5. So instead of x, we're going to put f of x in its place. So it's going to be 4. F of x will take the place of the x here, and then I'll still have my minus 5. Now we're going to substitute the value of f of x for, so function f was 3x squared plus 2x plus 1. Now these were given. If you're saying, where are you getting those? They're given way up here. Right, there's your f of x, and there's your g of x. So we're using the same function for this question for both parts, 1 and 2. Don't forget your minus 5 at the end here. Now this one will be a little bit easier to clean up. I don't have any binomials to square, so I've got 12x squared plus 8x. 4 times 1 is 4. Take away 5 is a negative 1. So that's called composition of functions. So that's where you're substituting not just a single number or a variable, you're substituting an entire function into another function. You should also be able to read function notation from graphs. I like this little, so let's suppose I had this graph, and let's see if we can figure out the answer for this. So it says 3f at 1. This is understanding function notation. This is saying when x is 1, what is the y value? When x is 1, the y value is 4. So f of 1 is equal to 4 minus 5 brackets f at 3. So that says when x is 3, what is the y value? When x is 3, the y value is 3. Minus 7 f at 0. When x is 0, what is the y value? It is 2. Right? X is 0, y is 2. Close that off. You got a 2. F at negative 2. Go to function f. When x is negative 2, the y value is also negative 2. Take away 3. F at negative 4. So when the x value on this graph is negative 4, what is the y value? The y value is also negative 4. Now I don't like that a lot of these gave you the same answer, but I'm just reading them off the graph. The y value at the particular x values. 3 times 4 is 12. 3 subtract 14 is a negative 11. Negative 4 plus 12. 12 plus 55 over 8. 67 over 8, which does not reduce. So that's how you read function notation from a graph. And that's not really anything new. It's just sometimes students don't understand the connection between function notation and how it's really just getting the y values. So if I just translate, let's pick this one for example. To translate that into a word statement, this means find y when x equals 0. Find y when x is negative 4. Find y when x is negative 2 on the function f. Well, this graph is a picture of function f, which allowed us to get those values. All right, so that's taking our knowledge of function notation, the basic things that we had learned prior to Pre-Calc 12a, extending it a little bit to combine functions through either addition, subtraction, multiplication, or division, which was the first samples that I showed you, and then looking at even further where you do what are called compositions of functions, and that's where you take a function and substitute it into a function for the variable. Okay, so there will be a couple of worksheets to follow for practice on this. If you do run into any problems, as always, please reach out through the Need Help section in your class notebooks, and I will do what I can to get you pointed in the right direction. Thank you for watching.